Hello and welcome to this session on data science with Python. So what are we going to do in this session? We will talk about what is data science and some of the basics of Python. As you may be aware, data science, we use either Python or R as some of the tools and programming languages. So this session, the focus is on Python. So we will talk about the basics of Python, why to learn Python, how to install Python, and then we will talk about some of the important libraries which are required for data analysis. And then we will go into a little bit of details about exploratory data analysis, and we will take an example there of loan prediction, and we will see a little bit about data wrangling using Pandas, which is one of the libraries of Python. And then we will end up with small predictive model or logistic regression model, which is a part of machine learning. And in case you need more details about machine learning in this session, we will probably not go into the details of machine learning. There is a separate session you might want to look at. There is a separate video on machine learning. You might want to take a look at that if you need more details. Here we are just giving a quick overview to see how we can use the Scikit-Learn library. So we will not go into a lot of details about the basics of machine learning. All right, so with that, let's move forward. So what is data science? Data science is about finding insights from the data. So if there is a lot of data, if you have sufficient data, how to analyze and find some insights out of it. This is what is data science all about. A couple of examples here. Customer prediction. Now, let's say you have a customer base and you want to find out who are most likely to buy your product. So you can use from your past behavior, you can probably develop a model and try to predict who are the people out of the 1,000 leads or potential customers who will actually buy. So there may be some patterns that you can use to predict. Similarly, service planning. So for example, you're running a restaurant and you want to know how many people will be coming or how many customers will be visiting your restaurant on a given day. Now, based on your historical data, you can build a model to predict that as well, so that there is no wastage of food and so on and so forth. So these are very quick and easy examples of how data science can be used in business. Now let's talk about Python. For doing data science, we need some kind of a programming language or a tool and so on. So this session will be about Python. There are other tools like, for example, R, and we will probably do a separate video on that. But this session is on Python, and you must have already heard Python is really becoming very popular. Everybody is talking about Python, not only data science, in IoT and AI and many other places. So it's it's getting very popular. So if you are not yet familiar with Python, this may be a good time to get started with it. So why do we want to use Python? So basically, Python is used as a programming language because it is for data science, because it has some rich tools from a mathematics and from a statistical perspective. It has some rich tools. So that is one of the reasons why we use Python. And if you see some of the trends, if you're probably tracking some of the trends, you will see that over the last few years, Python has become programming language of choice, and especially for data science, SAS was earlier one of the most popular tools, but now increasingly Python is being used for doing data science, and of course as well as R. One of the reasons, of course, is that Python and R are open source compared to SAS, which is a commercial product. So that could definitely be one explanation. But beyond that, I think it is the ease of understanding this language, the ease of using this language, which is also making it very popular, in addition to the availability of fantastic libraries for performing data science. What are the other factors? There are speed, then there are availability of number of packages, and then of course the design goal. All right, so what are each of these? Design goal. Primarily, the syntax rules in Python are relatively intuitive and easy to understand. Thereby, it helps in building applications with concise and readable code base. So with a few lines of code, you can really achieve a lot of stuff. And then there are a lot of packages that are available that have been developed by other people, which can be reused. So we don't have to reinvent the wheel. And last but not least, the speed. So Python is a relatively faster language. Of course, it is not as fast as, let's say, C or C++, but then relatively it is still faster. So these are the three factors which make Python the programming language of choice. So if you want to get started with Python, the first thing obviously is to install Python. So there is some documentation, there are some steps that you need to follow. So we will try to briefly touch upon that. Otherwise, of course, there is a lot of material available on how to install Python and so on. You can always look around, but this is one of the, again, there are different ways in which you can also install Python. So we will use the Anaconda path. There is a packaging tool called Anaconda. So we will use that path. You can also directly install Python, but in our session we will use the Anaconda route. So the first thing you need to do is download Anaconda, and this is the path for that. And once you click on this, you will come to a page somewhat like this, and download, you can do the corresponding download based on whether you have a Windows or Ubuntu. There is also a download possible for, or package available for Ubuntu if you are doing something on Ubuntu. So based on which operating system, in fact this page will automatically detect which operating system you are having, and it will actually suggest. So for example, you see here, if you're running Mac OS, then it will automatically detect that you have Macs, and the corresponding installers will be displayed here. Similarly, if you're on some flavor of Linux like Ubuntu or any other, then you will get the corresponding download links here. And then beyond that, you can also select which version of Python you want to install. Of course, the latest version is in the 3.x range at the time of recording. This 3.6 is one of the latest versions, but some of you may want to do or start with the earlier version, which is Python 2.7, 2.x, and you can download that as well. If you don't have anything installed, then my suggestion is start with Python 3.6. All right, so once you do that, you will be able to install Python and you will be able to run Jupyter Notebook. Okay, so now that you know how to install Python, and if you have installed Python, let's take a look at what are the various libraries that are available. So Python is a very easy language to learn, and there are some basic stuff that you can do. For example, adding or printing a hello world statement and so on without importing any specific libraries. But if you want to perform data analysis, you need to include or import some specific libraries. So we are going to talk about those as we move forward. So Pandas, for example, is used for structured data operations. So if you, let's say, are performing something on a CSV file, you import a CSV file, create a data frame, and then you can do a lot of stuffs like data munging and data preparation before you do any other stuff, like for example machine learning or so on. So that's Pandas. SciPy, as the name suggests, it provides more scientific capabilities, like for example it has linear algebra, it has Fourier transform, and so on and so forth. Then you have NumPy, which is a very powerful library for performing n-dimensional or creating n-dimensional arrays, and it also has some of the stuff that is there in SciPy, like for example linear algebra and Fourier transform and so on and so forth. Then you have Matplotlib, which is primarily for visualization purpose. It has again very powerful features for visualizing your data, for doing the initial, what is known as exploratory data analysis, for doing univariate analysis, bivariate analysis. So this is extremely useful for visualizing the data. And then Scikit-Learn is used for performing all the machine learning activities. If you want to do anything like linear regression, classification, or any of this stuff, then the Scikit-Learn library will be extremely helpful. In addition to that, there are a few other libraries, for example, networks and iGraph. Then of course a very important one is TensorFlow. So if you are interested in doing some deep learning or AI related stuff, then it would be a good idea to learn about TensorFlow, and TensorFlow is one of the libraries. There is a separate video on TensorFlow, you can look for that, and this is one of the libraries created by Google, open source library. So once you're familiar with machine learning, data analysis, machine learning, then that may be the next step to go to deep learning and AI. So that's where TensorFlow will be used. Then you have Beautiful Soup, which is primarily used for web scraping, and then you take that data and then analyze and so on. Then OS library is a very common library. As the name suggests, it is for operating system. So if you want to do something on creating direct directories or folders and things like that, that's when you would use OS. Alright, so moving on, let's talk in a little bit more detail about each of these libraries. So SciPy, as the name suggests, is a scientific library, and it very specifically, it has some special functions for integration and for ordinary differential equations. So as you can see, these are mathematical operations or mathematical functions. So these are readily available in this library, and it has linear algebra modules, and it is built on top of NumPy. So we will see what is there in NumPy. So this is again, as the name suggests, the num comes from numbers. So it is a mathematical library, and one of its key features is availability of an n-dimensional array object. It is a very powerful object, and we will see how to use this. And then of course you can create other let's say objects and so on. And it has tools for integrating with C, C++, and also Fortran code. And then it of course also has linear algebra and Fourier transformation and so on, all these scientific capabilities. Okay, what else? Pandas is another very powerful library, primarily for data manipulation. So if you're importing any files, you will want to create it like a table. So you will create what is known as data frames. These are very powerful data structures that are used in Python programming. So Pandas library provides this capability. And once you import the data into data frame, you can pretty much do whatever you're doing like in a regular database. So people who are coming from a database background or SQL background would really like this, because it is they will feel very much at home, because it feels like you're viewing a table or using a table, and you can do a lot of stuff using the Pandas library. Now there are two important terms or components in Pandas, series and the data frame. I was just talking about the data frame. So let's take a look at what are series and what is a data frame. So within Pandas we have series and data frame. So series is primarily, some of you may also be knowing this as let's say an array. So it's a one-dimensional structure, data structure if you will. So in some other languages we may call it as an array, or maybe some others probably an equivalent of a list. In R perhaps, I'm not very sure on that aspect, but yes. So this is like a one-dimensional storage of information. So that is what is series. Whereas data frame is like a table. So you have a two-dimensional structure, you have rows and you have columns, and this is very, people, as I said, who are familiar with SQL and databases will be able to relate to this very quickly. So you have like a table, you have rows and columns, and then you can manipulate the data. So if you want to create a series, this is how you would create a code snippet. And as you can see, the programming in Python is very simple. There are no major overheads. You just need to import some libraries which are essential, and then start creating objects. So you don't have to do additional declaration of variables and things like that. So that is, I think, one key difference between Python and other programming languages. And what does this series contain? It has to contain these numbers 6346, and X is my object consisting of the series. So if you just say X, it will display the contents of X, and you will see here that it creates a default index. Then you have data frame. So if you want to create a data frame, as you can see, the series is like a one-dimensional structure. There is just like a row, one row of items, whereas a data frame looks somewhat like this. It is a two-dimensional structure. So you have columns in one dimension, and then you have rows in the other dimension. How do you create a data frame? You need to rather import Pandas, and then you import. In this case, we are basically creating our own data. So that's the reason we are importing NumPy, which is one of the libraries we just referred to a little bit before. So we are using one of the functionalities within NumPy to create some random numbers. Otherwise, this is not really mandatory. You probably will be importing the data from outside, maybe some CSV file, and import into the data frame. So that's what we are doing here. So in this case, we are creating our own test data. That's the reason we are importing NumPy as NP, and then I create a data frame saying pd.dataframe. So this is the keyword here. Similarly here in this case, while creating series, we said pd.series, and then you pass the values. Similarly here, you're saying pd.dataframe. Now in order to create the data frame, it needs the values in each of these cells. What are the values in the rows and what are the values in the columns? So that in our example, we are providing using this random number generator. So np.random is like a class or a method that is available in NumPy, and then you are saying, okay, generate some random numbers in the form of a 4x3 matrix or 4x3 data frame. The 4 here indicates the number of rows and the 3 here indicates the number of columns. So these are the columns, 0, 1, 2 are the columns, and these are the rows. Here 0, this is 1, this is 2, this is 3. Okay, and once again it will, when you display df, it will give us a default index. There are ways to omit that, but at this point we will just keep it simple. So it will display the default index and then the actual values in each of these rows and columns. So this is the way you create a data frame. So now that we have learned some of the basics of Pandas, let's take a quick look at how we use this in real life. So let's assume we have a situation where we have some customer data and we want to kind of predict whether the customer's loan will be approved or not. So we have some historical data about the loans and about the customers, and using that we will try to come up with a way to maybe predict whether loan will be approved or not. So let's see how we can do that. So this is a part of exploratory analysis. So we will first start with exploratory analysis. We will try to see how the data is looking. So what kind of data? So we will, of course, I'll take you into the Jupyter notebook and give you a quick live demo. But before that, let's quickly walk through some of the pieces of this program in slides, and then I will take you actually into the actual code and do a demo of that. So the Python program structure looks somewhat like this. The first step is to import all the required libraries. Now, of course, it is not necessary that you have to import all your libraries right at the top of the code, but it is a good practice. So if you know you are going to need a certain set of libraries, it may be a good idea to put, from a readability perspective, it's a good practice to put all the libraries that you're importing at the beginning of your code. However, it is not mandatory. So in the middle of the code somewhere, if you feel that you need a particular library, you can import that library and then start using it in the middle of the code. So that's also perfectly fine. It will not give any errors or anything. However, as I said, it's not such a good practice. So we will import all the required libraries. In this case, we are importing Pandas, NumPy, and Matplotlib. And in addition, if we include this piece of code, %matplotlib inline, what will happen is all the graphs that we are going to create, the visualizations that we are going to create, will be displayed within the notebook. So if you want to have that kind of a provision, you need to have this line. So it's always a good idea when you're starting off. I think it's a good idea to just include this line so that your graphs are shown in line. Okay, so these are the 4. We will start with these 4 lines of code. Then the next step is to import your data. So in our case, there is a training data for loans by the name loan p_train.csv, and we are reading this data. So in this case, you see here, unlike the previous example where we created a data frame with some data that we created ourselves, here we are actually creating a data frame using some external data, and the method is very straightforward. So you use the read_csv method, and it is a very intuitive function name, and you say pd.read_csv and give the path of the file, CSV file. That's about it, and then that is read into the data frame df. This can be any name. We are calling it df. You can call xyz, anything. There's a name, just the name of the object. So head is one of the methods within the data frame, and it will give us the first 5. So this is just to take a quick look. Now you have imported the data. You want to initially have a quick look how your data is looking. What are the values in some of the columns and so on and so forth, right? So typically you would do a head, df.head, to get the sample of, let's say, the first few lines of your data. So that's what has happened here. So it displays the first few lines, and then you can see what are the columns within that, and what are the values in each of these cells, and so on and so forth. You can also, typically you would like to see if there are any null values, or are there any, is the data for whatever reason is invalid or looking dirty for whatever reason, some unnecessary character. So this will give a quick view of that. So in this case, pretty much everything looks okay. Then the next step is to understand the data a little bit overall for each of the columns. What is the information? So the describe function will basically give us a summary of the data. What else can we do? Pandas also allows us to visualize the data, and this is more like a part of what we call it as univariate analysis. That means each and every column you can take and do some plots and visualization to understand data in each of the columns. So for example, here the loan amount column we can take, and then the hist method will create a histogram. So you take all the values from one column, which is loan amount, and you create a histogram to see how the data is distributed, right? So that's what is happening here. And as you can see, there are some extreme values. So this is again to identify, do we have to do some data preparation? Because if the data is in a completely haphazard way, the analysis may be difficult. So these are the initial or exploratory data analysis is primarily done to understand that and see if we need to do some data preparation before we get into the other steps like machine learning and statistical modeling and so on. So in this case, we will see that here by plotting this histogram, we see that there are some extreme values. So there are some values, a lot of it is around 100 range, but there is also something, one or two observations in the 700 range. So it's pretty scattered in that sense, or they're not really scattered, distributedly scattered, but it is randomly scattered. So the range is really huge. So what can we do about this? So there are some steps that we need to do, normalization and so on. So we'll see that in a bit. So this is for one of the columns. Let's take another column, which is applicant income. Similar situation. You have most of your observations in this range, but there are also some which are far off from where most of the observations are. So this also has some extreme values. So we'll have to see what can be done. Credit history is the binary value. So some people have a 0 value and some will have credit history of 1. This is just like a flag. So this basically is telling us how many people have a 1 and how many people have 0. So looks like majority of them have a value of 1 and a few, about 100 of them, have a value of 0. Okay, what else can we do? So we now understood a little bit about the data. So we need to do some data wrangling or data munging and see if we can bring in some kind of normalization of all this data, and we will kind of try to understand what is data wrangling and before we actually go into it. Okay, so data wrangling is nothing but a process of cleaning the data. If let's say there are multiple things that can happen. In this particular example, there were no missing values, but typically when you get some data, very often it will so happen that a lot of values are missing. Either they are null values or there are a lot of zeros. Now you cannot use such data as it is to perform some, let's say, predictive analysis or perform some machine learning activities and so on. So that is one part of it. So you need to clean the data. The other is unifying the data. Now, if these ranges of this data are very huge, some of them are going from, some columns are going from 0 to 100,000 and some columns are just between 10 to 20 and so on. These will affect the accuracy of the analysis. So we need to do some kind of unifying the data and so on. So that is what data wrangling is all about. So before we actually perform any analysis, we need to bring the data to some kind of a shape so that we can perform additional analysis, actual analysis on this and get some insights. Now, how do we deal with missing values? This is a very common issue when we take data or when we get data from the business, when a data scientist gets the data from the business. So we should never assume that all our data will be clean and all the values filled up and so on, because in real life, very often the data will be dirty. So data wrangling is the process where you kind of clean up the data. First of all, identify whether the data is dirty and then clean up. So how do we find some data is missing? So there are a few ways. You can write a small piece of code which will identify if for a given column or for a given row, any of the observations are null primarily. So this line of code, for example, is doing that. It is trying to identify how many null values or missing values are there for each of the columns. So this is a lambda function, and what we are saying is find out if a value is null and then you add all of them. How many observations are there where this particular column is null. So it does that for all the columns. So here you will see that For loan ID, obviously it's an ID, so there are no null values or missing values. Gender has about 13 observations where the values are missing. Similarly, marital status has 3 and so on and so forth. So we'll see here, for example, loan amount has 21 observations where the values are missing. Loan amount term has 14 observations and so on. So we'll see how to handle this missing values. So there are multiple ways in which you can handle missing values. If the number of observations are very small compared to the total number of observations, then sometimes one of the easy ways is to completely remove that data, or delete that record, exclude that record. So that is one way of doing it. So if there are, let's say, 1,000,000 records and maybe 10 records are having missing values, it may not be worth doing something to fill up those values. It may be better off to get rid of those observations, right? So that is, the missing values are proportionately very small. But if there are a relatively large number of missing values, if you exclude those observations, then your accuracy may not be that very good. So the other way of doing it is, we can take a mean value for a particular column and fill up wherever there are missing values, fill up those observations or cells with the mean value. So that way what happens is, you don't give some value which is too high or too low, and it somehow fits within the range of the observations that we are seeing. So this is one technique. Again, it can be case to case, and you may have to take a call based on your specific situation, but these are some of the common methods. If you see in the previous case, loan amount had 21, and now we went ahead and filled all of those with the mean value. So now there are 0 with missing values. Okay, so this is one part of a data wrangling activity. What else you can do? You can also check what are the types of the data. So df.dtypes will give us what are the various data types. So alright. So you can also perform some basic mathematical observations. We have already seen that mean we found out. So similarly, if you do call the mean method for the data frame object, it will actually perform or display or calculate the mean for pretty much all the numerical columns that are available in this, right? So for example, here applicant income, co-applicant income, and all these are numerical values. So it will display the mean values of all of those. Now, another thing that you can do is, you can actually also combine data frames. So let's say you import data from one CSV file into one data frame and another CSV file into another data frame, and then you want to merge these because you want to do an analysis on the entire data. Okay, one example could be that you have data in the form of CSV files, one CSV file for each month of the year, January, February, March, each of these are in a different. So you can import them into, let's say, 12 data frames, and then you can merge them together as a single data frame, and then you perform your analysis on the entire data frame or the entire data for the year. So that is one example. So how do we do that? This is how we do. Again, in this case, we are not importing any data. We are just creating some random values, using some random values. So let's assume I have a data frame which is by the name 1, and I assign some random values here, which is a 5x4 format. So there are 5 rows and 4 columns, and this is how my data frame 1 looks. And then I create another data frame, which is data frame 2, again random numbers of the format 5x4, and I have something like this. Now I want to combine these two. How do I combine these two? I can use the concatenate or concat method, and I can combine these two. So pd.concat, and it takes the data frames 1 and 2. If you have more of them, you can provide them, and it will just simply add all of them, merge all of them, or concatenate, whatever you call, whichever term you call, it will. So of course we have to make sure that the structure remains the same. Like I said, this could be, let's say, sales data coming for 12 different months, but each of the files has the same structure. So now you can combine all of them, merge all of them using the concat method. If we have, let's say, structure is not identical, then what will happen? Let's say we have these two data frames. One has a column by the name key, and the second column is lval, and a second data frame which has a column by the name key, but the second column by the name rval, not lval. So you see here the structure is not identical. So you can still combine them, but then the way they get combined or merged is somewhat like this. So it takes the key as a common parameter between them. Some common column has to be there, otherwise this will not work. And then we have to use merge instead of concatenate. And when we do a merge, then we get the result will be in this format. What it does is it uses the key as a common thread between them, and then it kind of populates the values accordingly. So if you see here, the first one had foo and bar for key, and then it had L values of 1 and 2, right? So if we go back, foo and bar had 1 and 2 L values. So that's what we see here, 1 and 2. Whereas in the right data frame, we had foo, bar and bar as a second time, and then our values are 3, 4 and 5. So what it has done for foo, it has put for the existing, right? For foo is already existing because it has come from left. So it will just put the value of R val here, which is 3. Similarly, it will put 4 here because for bar, if you go back, for bar it is the value is 4. And since it has one more value of bar, it will go and add this 5 as well. The only thing here is that this one had, for example, left had only 2 values and only 1 value for bar. But since we are appending or merging, and there are 2 key values with the bar, therefore it will kind of repeat the value of L val here. So that's what we are seeing in this case, right? So L value appears twice, the number 2 appears twice, but that is because R value, there are 2 of them. Okay. All right. So that is how, when you don't have identical structure, that's how you merge. Now we will talk a little bit about Scikit-Learn. So Scikit-Learn is a library which is used for doing machine learning or for performing machine learning activities. So if you want to do linear regression, logistic regression, and so on, there are easily usable APIs that you can call. And that's the advantage of Scikit-Learn. And it provides a bunch of algorithms. So I think that is the good part about this library. So if you want to use Scikit-Learn, obviously you need to import these modules, and also there are some sub modules you may have to import based on what you're trying to use. Like for example, we know if we want to use logistic regression. Again, people who are probably not very familiar with machine learning, there is a separate module for machine learning. You may want to take a look at that, but we will just touch upon the basics here. So machine learning has some algorithms like linear regression, logistic regression, and random forest classification, and so on. So that is what we are talking about here. So those algorithms are available, and if you want to use some of them, you need to import them and from the Scikit-Learn library. So Scikit-Learn is the top level library, which is basically SciKiLearn, right? And then it has a kind of subparts in it. You need to import those based on what exactly you will be or which algorithm you will be using. So let's take an example as we move, and we will see that whenever we perform some machine learning activity, those of you who are familiar with machine learning will already know this. We split our labeled data into 2 parts, training and test. Now, there are multiple ways of splitting this data. How do we, some people do it like 50-50, some people do it 80-20, which is training is 80 and test is 20, and so on. So it is an individual preference. There are no hard and fast rules. By and large, we have seen that training data set is larger than the test data set. And again, we will probably not go into the details of why do we do this at this point, but that's one of the steps in machine learning. So Scikit-Learn offers a readily available method to do this, which is train test split. All right. So in this example, let's say we are taking the values x and y are our values. X is the independent variables and y is our dependent variable. Okay. And we are using these two. And then I want to split this into train and test data. So what do? We import the train test split submodule from within Scikit-Learn, which is SciKiLearn, right? So within that we import train test split, and then you call this train test split method or function or whatever you call it and pass the data. So x is all the values of the independent variables and y is our labels. So you pass x and y, and then you specify what should be your size of the test data. So only one you need to specify. So if you say test size is 0.25, it is understood that train size will be 0.75. So you're telling what should be the ratio of the split. So technically nothing prevents you from giving whatever you like here. So you can give test as 80 and train as 20, so whichever way, but then the normal practice is you will have the training data set would be larger than the test data set, and typically it would be 80-20, 75-25 or 65-35, something like that, right? So that is the second parameter, and this is just to say that the data has to be randomly split. So it shouldn't be like you take the first 75% and put it in training and then the next 25% and put it in test, so such a thing shouldn't happen. So we first set the state, random state, so that the splitting is done in a very random way. So they are randomly picked up the data and then put it into training and test, and then this results in these 4 data frames. So X train and X test and Y train and Y test. Okay, so that is basically the result it will return. Now that the splitting is done, let's see how to implement or execute logistic regression. So in logistic regression, what we try to do is try to develop a model which will classify the data. Logistic regression is an algorithm for supervised learning for performing classification. So logistic regression is for classification, and usually it is binary classification. So binary classification means there are 2 classes. So either like a yes, no, or for example, customer will buy or will not buy. So that is a binary classification. So that's where we use logistic regression. So let's take a look at the code, how to implement something like that using Scikit-Learn. So the first thing is to import this logistic regression submodule or subclass, whatever you call it, and then create an instance of that. So our object is classifier. So we are creating an object by the name. This is a name, by the way. You can give any name. In our case, we are saying classifier. We say classifier is equal to logistic regression. So we are creating an instance of the logistic regression variable or class or whatever. Okay. And you can pass a variable or a parameter rather, which is the random state is equal to 0. And once you create the object, which in our case is named classifier, you can then train the object by calling the method fit. So this is important to note. We don't call there is no method like train here, but we call what is known as, there is a method called fit. So you're basically, by calling the fit method, you're training this model. And in order to train the model, you need to pass the training data set. So X underscore train is your independent variables, the set of independent variables, and Y underscore train is your dependent variable or the label. So you pass both of these and call the fit function or fit method, which will actually result in the training of this model classifier. Now, this is basically showing what are the possible parameters that can be passed or initiated when we are calling the logistic or the instance of logistic regression. So this is, but you can also look up the help file if you have installed Python. So some of these are very intuitive, but some you may want to take a look at the details of what exactly they do. All right, so moving on. Once we train the model by calling fit, then the next step is to test our model. So this is where we will use the test data. You need to pay attention here. Here I am calling, so there are 2 things. One is, in order to test our data, we have to actually call what is known as the method known as predict. Right? So here, this is where, so the training is done. Now is the time for inference, isn't it? So we have the model. Now we want to check whether our model is working correctly or not. So what do? You have your test data. Remember, we split it, 25% of our data was stored here, right? We split it into test and training. So that 25% of the data we pass to and call the method predict, so that the model will now predict the values for Y. Right, so that's why here we are calling it as Y underscore predict. And if we display here, as I said, this is a logistic regression, which is basically binary classification. So it gives us the results like yes or no in this particular case. And then you can, so this is what the model has predicted or model has classified. Now, but we also know we already have the labels for this. So we need to compare with the existing labels, with the known labels, whether this classification is correct or not. So that is where is the next step, which is basically calculating the accuracy and so on will come into play. Okay, so in this case, the first thing, most important thing to note is we do the prediction using predict, and here we are passing X underscore test and not train, right? In this case, we did X and Y train. So again, one more point to be noted here. In case of training, we will pass both the independent variables and also the dependent variables, because the system has to internally, it has to verify. That is what is the training
training process. So what it will do, it will take the X values, it will try to come up with the Y value and compare with the actual Y value, right? So that is what is the training method. So that's why we have to pass both X as well as Y. Whereas in case of predict, we don't pass both, we only pass because we are pretending as if this is the actual data. So in actual data you will not have the labels, isn't it? So we are just passing the independent variables, and the system will then come up with the Y values, which we will then, okay, remember we also know the actual value, so we will compare this with the actual values and we will find out whether how accurate the model is. So how do we do that? We use what is known as a confusion matrix. So this is also readily available in the Python library. So we import this confusion matrix, and some of you who already know machine learning will find this familiar, but those who are new to machine learning, this confusion matrix is nothing but this matrix, this kind of a matrix, which basically tells how many of them are correctly predicted and how many of them are incorrectly predicted. So some of the characteristics, let's quickly spend some time on this confusion matrix itself. The total numbers out here, these are just the numbers, these are like number of observations. Then the accuracy is considered to be highest when the numbers or the sum of the numbers across the diagonals is maximum, okay, and the numbers outside of the diagonals should be minimum. So which means that if this model was 100% accurate, then the sum of these two, there would have been only numbers in these two along the diagonal, this would have been 0 and this would have been 0. Okay, so that is like 100% accurate model. That is very rare, but just that you are aware. So just to give an idea. Okay, all right. So once you have the confusion matrix, you then try to calculate the accuracy, which is in a percentage. So there are two things that we can do from a confusion matrix, or that we can calculate from a confusion matrix. One is the accuracy and the other is the precision. What is the accuracy? Accuracy is basically a measure of how many of the observations have been correctly predicted. Okay, so let's say this is a little bit more detailed view of the confusion matrix. It looks very similar like as we saw in this case, right? So this is a 2 by 2 matrix. That's what we are seeing here, 18, 27, 2, 103. So 18, 27, 2, 103. Now, but what are these values? That is what is kind of the labels are shown here in this. So there are altogether 150 observations. So as I said, the sum of all these four, right? 18 plus 27 plus 103 plus 2 is equal to 150. That's the first thing we have to observe. The sum of all these values will be equal to the sum of test observations, number of test observations. We have 150 test observations, because remember we had about 500. We split that into 2575. So that is why we have 150 here and I think 350 in the training data set. Okay, so that we get the numbers correct. So that's the first thing. Now the next thing is, let's take a look at the actual values. This view is the actual view. So there are actually, right, so in the actual data we have labels yes and no. So as per the actual data, there are 45 observations tagged as no, and similarly there are 105 observations that are tagged as yes or labeled as yes. Okay, now I know for the first time when you're seeing this it may be a little confusing, but just stay with me. Okay, so this is the actual part of it, and this side tells us the predicted part of it. So our model has predicted, and it has totally predicted 20 of them as no, right? So that is what this is. Totally 20 of them it has predicted as no, and it has predicted 130 of them as yes. Okay, I hope this part is clear. So before we go into the middle part, let us first understand what exactly are these numbers. So actually tagged as no, there are 45 total. Actually tagged as yes, there are 105. And predicted no, there are 20. Predicted as yes, there are 130. This is the result from our model. Okay, this is the result from our model, and this is the actual value which we already know because this is our label data. That's the first thing. Now let us take a look at each of these individually. Okay, now what are the options we have? Once again, okay, so now what is happening here? Let us look at these values. So this 18 says that these are actually tagged as no, and the model has also predicted as no, which means this is what is known as a true positive, right? Or true negative, sorry, right? Which means that our model has predicted it correctly. It is negative because it says no. So, and it has also predicted no, so it is known as what is known as true negative. Okay, now let's come to this side of it. That way we are talking about the diagonal. Remember I said most of the values should be in the diagonal. Okay, so that means these 18 are correctly tagged. They are labeled as no and our model has predicted as no. So these are correctly tagged and these are known as true negative. Okay, similarly, if we come diagonally down, there are 103 observations which are labeled as yes, actual value is yes, and our model has also predicted as yes, and these are known as true positive values. Positive because of this yes. Okay, right? So what is important is this is true, this is also true. So we have to make sure that the maximum number of values are in the true section. Okay, true positive and true negative. That's the reason I said the sum along the diagonal should be maximum. Now let's say if our model was 100% accurate, this sum, in this case it is only 103 plus 18, which is 121. But if our model was accurate, the sum of these two would have been 150. That means it's a perfect model. Okay, all right. Now what else? Since we covered these two, let's also cover these two. So here this says that 27 of them were actually labeled no, but our model has predicted as yes. That means this is wrong, right? Similarly, these are two of them where the actual value is yes, but our model has predicted as no. That means it's a wrong prediction. So you get the point? So therefore, along the diagonals are the correct values, whereas in other places it is all wrong values or wrong predictions. Okay. Now, how do we calculate accuracy from this information? So the way to calculate accuracy is, so we say, okay, there are total observations are 150. And what are the correctly predicted values? These are the correctly predicted values, which is 18 plus 103. So this will give us our accuracy. So 103 plus 18, which is 121, divided by our total observations, which is 150, is our accuracy, which is 0.8, or we can say it is 80%. Okay. Now, there is another concept called precision. So precision is given by the formula true positives divided by the predicted positives, totally predicted positives. Okay, what do we mean by that? Which are the true positives here? Remember, which are the true positives? We just recall, we just talked in the previous slide. Which are the true positives you see here? So this 103 are the true positives, which means that the value is positive, actual value is positive, predicted value is also positive. So that's why it's called a true positive. So 103 divided by, so that is our true positive, 103 divided by totally predicted as yes. Now what is totally predicted as yes? Remember, 130 of them have altogether been predicted as yes. Not that they are correctly predicted, only 103 have been correctly predicted, but 130 of them have been predicted as yes. So precision is basically the ratio of these two. Out of the totally predicted, how many of them are actually true? That ratio. So 103 by 130, which is again about 80%, is the precision. That's how you calculate precision. So this is just a simple formula and a term that you need to remember. So accuracy is, you need to take total of true positive and true negative divided by the total number of observations, whereas precision is true positives divided by the totally predicted positives. Okay, so that is our accuracy and precision. Now what we did, the accuracy calculation was manual, but we can also use some libraries which are already existing and the functions within that library. So Scikit-Learn provides one such method. So for example, accuracy underscore score is one such method. So if you use that and pass your test and predicted values, only the y you need to pass, right? The dependent variable values. So if you pass that, it will calculate it for you. So in this case, again, as you can see, it still calculates the same, which is 80%, which we have seen here as well. Okay, so this can be done using the method. Great. So that's pretty much what we have done here. Before we conclude, let me take you into the code and show you how it actually looks. Okay, so this is our code. Let me run it. Okay, one by one. We have already seen most of the steps in the slides, so I will run this in the actual Jupyter Notebook. Some of you, if you're not yet familiar with Jupyter Notebook, again, there are other videos we created on how to install Jupyter Notebook and how to set up Jupyter Notebook and so on. In this tutorial also, there was one slide on how to install Python and Jupyter Notebook. If you have not yet done, please do that, so that then you can actually walk through this code while you're watching this. Okay, so what are we doing here? We are importing the libraries, required libraries. Recall here we have Pandas, we have NumPy, and for visualization, we have matplotlib, and this line is basically reading the CSV file. So we have the CSV file locally on our local drive, and this is where I'm checking the data. So I'm starting with my exploratory analysis, how the data is looking. So it looks good. There are no major missing values or anything like that. So it will display all the columns, and it will show me the first 5 rows when I'm using this head function. And then I want to see a kind of a summary of each of the numerical columns. So that's what I'm doing here. So these are the numerical columns, and it gives a summary like how many observations are there, what is the mean, standard deviation, minimum, maximum, and so on and so forth for each of them. And then you can do some visualization. So this is the visualization for this. Okay, the next step is to view the data visualization, and we will do that using a histogram for a couple of these columns. So in this case, I'm taking a look at the loan amount, and if I create a histogram, it displays the data here in the form of a histogram. One thing that we gather from this, as I mentioned in the slides as well, is how the data is kind of scattered. So while most of the values are in this range 0 to 300 range, there are a few extreme values around the 700 range. So that is one information we get from this histogram. Similarly, for the applicant income, if we draw a histogram, something similar we can see that while most of the values are in this range 0 to 20,000 range, there are a few in the range of 80,000 and probably 65,000 and so on. Okay, so the next step is to perform data wrangling, where we will check if any data is missing and how to fill those missing values and so on. So in this case, we will just check for all the columns, how many data or how many entries are there with missing values. So this is the result. So loan ID has all the columns or all the cells filled. Gender has 13 missing values. Marital status has 3 missing values, and so on and so forth. Loan amount has 21. And this is what we are going to show you how to remove these missing values. So when you have missing values, as I mentioned during the slide, there are a couple of ways of handling that. One is you can completely remove those, or you fill in with some meaningful values. So in this case, we will fill the missing values with the mean value of the loan amount. So let's go ahead and do that. And now if we check here, now loan amount, number of missing values is 0, because what we did was for all these 21 cells where the values were missing, we filled with the mean value of the loan amount. So now there are no more missing values for loan amount. We can do this for other columns as well, but this was just one example, so we have shown it here. Okay, so we will run this for credit history and loan amount term as well. And then if we calculate the mean of pretty much all the numerical columns, that's the method call. So df.mean will give us the mean of all the numerical values. And another thing that we can do is if you want to find out what are the data types of each of these columns, so you can call df.dtypes and get the data types. Of course, it may not be that very useful. Most of the cases is an object, but for example, this one it shows as int 64 and there are float 64 and so on and so forth. Now, in addition to doing the exploratory data analysis, we can do some machine learning activity as well. So in this case, we are going to do logistic regression. So this is the example that I have shown you in the slides as well. This is the actual code for that. All right. So the first step here is to import the libraries. And then the next step is to separate the independent variables and the dependent variables. So X is our independent variable and Y is our dependent variable. So we separate the data into 2 parts, and this will be our target as well, right? So that's how we separate it. Now we have to split the data into training and test data sets. As I mentioned during the slides, we use the train test split method, and when we call this and pass the independent variables and the dependent variables, and we specify the test size to be 0.25, which means the training size will be 0.75, which is nothing but you split the data into training data set, which is 75%, and test data set which is 25%. Okay, so once you split that, you will have all your independent variables data in xtrain, the training data, which is 75% of it. Similarly, independent variables for test will be in x_test, and dependent variables train will be in y_train, and dependent variable test will be y underscore test. Once we do this, we have to do a small exercise for scaling. Remember, we had some data which was kind of very scattered. There were some extreme values and so on. So this will take care of that so that the data is normalized, so that before we pass to our algorithm, the data is normalized so that the performance will be much better. The next step is to create the instance of logistic regression object. So that's what we are doing here. So classifier is our logistic regression instance, right? Classifier is equal to logistic regression, we are saying. So one instance of logistic regression is created, and then we call the training method. The name of the method actually is fit, but what it is doing is it is taking the training data. X is the training data, the independent variables, and Y is the dependent variables. So we are taking both of these and the model gets trained. So the method for calling the training is fit. Okay, so it gives us the output, and then once we are done with the training, we do the testing. And once again, just to recall, in the slides when I was showing you the slides also I mentioned, we don't pass Y here while we are testing. While for training we do pass Y, but right, so for fit we are passing X and Y, but for test we are only passing X, something you need to observe, because Y will be calculated by the model, and we will then compare that with the known value of Y to measure the accuracy. So that's what we will do here, and the method that is called here is predict. So this will basically create or predict the values of Y. Now we have in this case a binary classification. So the outputs are yes or no. Y indicates yes and N indicates no. So Y or N is the output. Now how do we measure the accuracy? As we have seen earlier, I described how confusion matrix works and how we can use confusion matrix for calculating the accuracy. That's what we are seeing here. So this is the confusion matrix, and then you want to do the measure the accuracy, you can directly use this method, and we find that it is 80%. So we, in the slides we have seen, when we calculate manually as well, we get an accuracy of 80%. Okay, let's go back to our slides and do a summary. So what we have done in this session, we talked about what is data science and why Python is being used, why it is becoming so popular, how to install Python, and we talked about the various libraries in Python like Pandas, SciPy, NumPy, and so on. And then we took a couple of examples and wrote the code and demonstrated the code for performing exploratory analysis and performing data wrangling or data manipulation. And then we, at the end, we did one example of machine learning using Scikit-Learn library and performed the logistic regression example. So with that, we come to the end of the session. If you have any queries, comments, please put them below, and you can also give your email ID so that we can get back to you if you have any questions. I hope you enjoyed the session. Thank you very much.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.